Welcome to today's Explainer. All right, let's just dive right in because today we are going to completely demystify REST APIs. We've specifically designed this journey to be incredibly beginner-friendly, taking you from the absolute foundational basics all the way up to advanced professional design and security concepts. So whether you're just starting out or looking to sharpen up your architecture skills, you are absolutely in the right place.
To kick things off, think about something you probably did the second you woke up this morning. You checked your phone's weather app, right? Have you ever wondered exactly how it fetches that daily data seemingly out of thin air? I mean, it doesn't store the entire world's weather data locally on your phone. That'd be literally impossible. Instead, it reaches out and asks another system for it. That invisible, lightning-fast conversation happening in the background? That is the exact magic we are exploring today.
So let's break down the jargon into plain English. API, Application Programming Interface. It's basically a contract. It defines exactly how two pieces of software are allowed to communicate with each other. It's how your weather app talks to the big Weather Bureau system. And REST, Representational State Transfer? Well, think of REST as the internet's absolute favorite set of rules for having that conversation. It's an architectural style that simply exchanges data over HTTP. You know, the exact same protocol your web browser uses every single day.
Here is our roadmap for today. First, what is a REST API? Second, REST versus SOAP versus GraphQL. Third, API design best practices. Fourth, the API lifecycle and documentation. Fifth, securing your API. And finally, the future of APIs.
Section 1. What is a REST API? The foundation.
Okay, so the whole foundation of API architecture relies entirely on two players, the client and the server. The application sending the request is the client, like your mobile weather app. The system sending the response is the server, like the Weather Bureau's massive database. Now, here's an absolutely crucial point about REST. It's a concept called statelessness. This means the server does not remember you. It doesn't save your client data between requests. When the server responds, it just fires back plain raw data. No graphical rendering, no pretty web visuals, just a pure data your app needs to function.
Section 2. REST versus SOAP versus GraphQL. Let's compare these models.
To make this really click, I love using a fast food analogy. Think of REST like a standard fast food menu. If you want a burger, you go to the burger counter. In REST, these counters are called endpoints, and they look just like standard web URLs. It uses a data format called JSON, which is incredibly lightweight and super easy for both us and computers to read. But here is the catch with the fast food setup. If you want a combo meal, like a burger, fries, and a soda, you might actually have to make 3 separate trips to 3 different endpoints. You end up getting maybe a bit too much data from one counter and not quite enough from another.
So how do the others compare? Well, if REST is our fast food menu, the foundational standard of the modern web, GraphQL is kind of like having a personal chef. With GraphQL, you send one single note to one endpoint, asking for exactly what you want, say just 1 bite of a burger and half a cup of soda. And the chef brings you exactly that. No overfetching, no underfetching. It's exactly why complex apps like Netflix absolutely love it. On the other end of the spectrum, we have SOAP. SOAP uses a much heavier XML format. Honestly, it's like wearing a heavy-duty, highly secure tuxedo. It's super safe, but nobody wants to wear a tuxedo to a fast food joint, right? It's a legacy protocol mainly used by older enterprise systems, banks, or shipping companies like FedEx, mostly because it relies on strict, formal contracts that virtually never change.
Section 3. API Design Best Practices. Let's build for success.
The ultimate goal of APIs is seamless integration. They literally exist to connect incredibly diverse software systems smoothly. But here's the thing. This beautiful visual harmony only happens out in the real world when developers stick to intuitive, standardized rules. If an API is poorly designed, oh man, integrating it becomes a massive headache of confusing, custom-coded functions.
The real secret to good design is taking a data-oriented approach rather than a function-oriented one. Good design uses simple nouns, like students, followed by a student ID. It directly points to the data. Bad design uses verbs and custom functions, like getStudent. Why? Because the HTTP protocol already has built-in operations that tell the server what action to take. Embedding verbs in your URL just duplicates information and creates a super steep learning curve for anyone trying to use your system. Uniformity is totally key here.
Speaking of those built-in HTTP operations, here is your standard toolkit for endpoints. Post to create something new, get to read it, and delete to, well, delete it. But let's pause for a second on updating data. You have put and patch. A beginner is probably just going to use put, which replaces the entire resource. But pro developers know that if a resource has, say, 50 properties and you only need to change one, overriding the whole thing is a huge waste of processing power. Actually, scratch that. It's a massive waste of bandwidth too. Using patch allows you to update just that specific partial property. It's a total game changer for efficiency.
Another brilliant efficiency hack is using query parameters for pagination. Imagine querying an API and it tries to send you 1 million student records all at once. Boom! It would literally crash your app. By simply adding parameters like limit equals 100 or an offset to your URL, you fetch data in manageable, bite-sized chunks. You can even use them to request only specific fields. When you are dealing with massive enterprise databases, this is an absolute must-do to save bandwidth.
Section 4. The API Lifecycle and Docs, Professional Workflows.
Okay, building an API isn't just opening a laptop and writing code. It follows a strict professional lifecycle. Step 1 is planning. Advanced teams don't just jump into coding. They map out blueprints using standards like the OpenAPI spec to make sure they hit all enterprise requirements first. Step 2 is building, where designers prototype the API using boilerplate code. And Step 3 is testing. And let me tell you, this is absolutely mandatory. You have to strength test against bugs and cyber attacks before a single endpoint ever goes live.
But listen, an API is literally only as good as its instruction manual. According to Postman, a massive API platform, teams that actually prioritize their documentation see way higher adoption rates and significantly fewer support tickets. You need a good mix here. Reference docs that outline every single endpoint, code samples so developers can literally copy-paste and see what requests actually look like, release notes for your system updates, and step-by-step tutorials to handhold beginners through tricky workflows like authentication. Good docs are the ultimate developer experience multiplier for sure.
Section 5. Securing your API. Let's protect those assets.
I want to anchor the stakes right now with a seriously jarring statistic from Salt Security. 95%. Let that sink in. 95% of organizations recently experienced an API security incident. Because APIs are the invaluable assets driving modern business innovation and connecting all our apps, they have become the absolute #1 target for cyber attackers today.
The Open Web Application Security Project, OWASP, tracks the top vulnerabilities here. And what's really terrifying is that attackers are totally moving away from traditional brute force attacks. Instead, they are using sneaky, low and slow tactics to manipulate core business logic. The #1 threat since 2019 is BOLA, or Broken Object Level Authorization. This accounts for about 40% of all API attacks. It happens when endpoints lack proper access controls. So an attacker just tweaks an ID in a URL, like changing user equals 1 to user equals 2, and boom, they can secretly access or modify someone else's highly sensitive data. So securing authentication tokens and strictly governing who can access what, that is completely non-negotiable.
Section 6. The Future of APIs. Looking toward 2026.
All right, let's step into the future. According to research from Neos Alpha, API ecosystems are growing exponentially more complex. We're moving way beyond basic server monitoring now. The future is all about deep API observability combined with continuous compliance. That means tracing dependencies across sprawling, messy microservices, and, crucially, monitoring AI agent-driven behavior and anomalies. APIs basically have to be designed to be state-aware and resilient enough to handle insanely complex data interactions, all without constant human intervention.
Which brings us right to our final thought for today. We've journeyed from a simple morning weather app all the way to the absolute frontier of artificial intelligence. As AI agents increasingly act as the primary consumers of APIs, executing rapid, automated actions entirely on our behalf, you really have to ask yourself, is your API ecosystem observable, secure, and resilient enough to handle an entirely automated future? I hope today's explainer gave you the tools and the confidence to start building that future. Keep learning, keep building, and I will catch you in the next one.